Number 29. What is the pH? I hope you do these questions before you watch the recording, okay? It's important to know what it is that you can do and what it is that you cannot do before you solve this, okay? Before you actually watch this. So, what is the pH of a solution obtained by mixing? We have 25 ml of sodium hydroxide. Always ask, what is sodium hydroxide? It's a base. Particularly, it's a strong base of a concentration 0.1 mol per liter. Okay, I have the volume and the concentration of a strong base with 15 ml of a strong acid that has the same concentration. What do you think will happen if you put a strong base and a strong acid together in the same medium? What do you think will happen? The acid will neutralize the base, or the base will neutralize the acid, however you want to say it. But there will be a reaction between both of them. هوني في trick كتير صغيرة. What you do is that you establish the reaction, you do the reaction, you see which one is in excess, which one is limiting, لتعرفوا what is the remaining species in your solution, and you find the pH according to that. التريك الصغيرة إنه you have a mixture of 25 ml of NaOH and 15 ml of HCl. It means that the total volume in the solution has changed. So your concentration is not 0.1 and it's not 0.15. You either calculate the new concentration, وكلنا بنعرفه by dilution, 25 times 0.1 على total, okay, اللي هو basically 40, 25 plus 15, or you establish the table, the reaction with number of moles, but then you have to divide by the total volume. So let's do it على صفحة بيضاء. Okay, number 29. In number 29, the given is 25 ml of HO minus that has a concentration of 0.1 mol per liter. خلينا نتأكد بس. Yep, 0.1 and 0.15. And then 15 ml of H3O plus يلي اجت من ال HCl, which is 0.15 mol per liter. You have an acid, you have a base. What will happen is called a neutralization reaction, where the acid, H3O plus, reacts with the base in a complete reaction. الاثنيناتهم are strong. Strong plus strong بيعطيكم complete. The incomplete أو reversible أو limited هي between limited, weak and weak. Sometimes, if the weak species, weak acid and weak base are far apart بالpKa scale, بعاد عن بعض بالpKa scale and along gamma, a reaction between them can be complete. But between strong, it's always complete. So, this will give you 2H2O. Establish the table, okay? But this time do it in number of mole because the concentration is not the same. What is the number of mole initially of H3O plus? كلنا نعرف C times V, which is basically 0.15 times 15, and this is in millimole. Pay attention. Okay, 25. خليني أكتب الكونسنتريشن بالأول لأنه بتغلطوا. In millimole, then you're multiplying mole per liter by milliliter, okay? And this is the value. What's 15 times 0.15? It's 2.25 millimole. 0.1 times 25 here, 2.5 millimole. Look at what you have in your solution, which is an excess, which is the limiting. This is your limiting. This value will be completely consumed, okay? So the change, هنكتبها هون, the change is according to the limiting اللي هو 2.25 millimole. 2.25 millimole. This is the change. This is the X. At the end of the reaction, we can also call it final equilibrium, but honey, I don't mean it's reversible. What you will have is a value that is approximately 0 for H3O+. Why don't we ever say 0? لأنه صرتوا تعرفوا إنه H3O+ will never be equal to 0. You can always calculate it from Kw اللي هي 10 to the negative 14. So we can actually call it a value of epsilon. And HO minus remaining will be 2.5 minus 2.25 millimole. So what do you have now in your solution? In the solution now I have the base. What is the value of the base? The number of mole of HO minus is equal to 2.5 minus 2.25 اللي هي 0.25 millimole. The concentration of HO minus is basically the number of moles, هي mole per liter, 0.25 millimole divided by, try to take milli with milli, okay, divided by 15 plus 25 milliliters. فكنت تحولوا لليترز, you have to change millimoles to mole. Only the milli will cancel the milli, because when you go from milli to something, it's times 10 to the power negative 3. So 0.25 divided by this, you get 6.25 times 10 to the power negative 3 mole per liter. I always prefer that you take at least 3 numbers after the point, okay? Now this value is greater than 3.2 times 10 to the power negative 7. عم نحكي هون عن ال validity of the strong base. So the pH دغري is 14 plus log ال HO minus اللي هي 6.25 times 10 to the power negative 3 mole. Remember, if it's less than 10 to the negative 8, رحنا على pH equals 7. If it's between the values, you go to quadratic. So this is equal to 11.8. Back to the question. 11.8. C'est ça. This is 29. Okay? Now it's 30. Now it's 30. Calculate the concentration of acetic acid, CH3COH, to obtain a solution where H3O plus is equal to 3.5 times 10 to the power negative 4. They gave you the value of H3O plus. Yani basically they gave you the value of X. And you already know, in CH3COH, when you put it in your solution, yani it reacts with H2O, to give you CH3COO minus مع H3O plus. If I'm working traditionally without any validity, without anything, أنا بقول at equilibrium, دغري at equilibrium, this will be C minus X, this will be X. Okay? Very simple. What is the value of X? They gave you the value of X هون. X is 3.5 times 10 to the power negative 4 mole per liter. Good. Ka, which is also given, is equal to X squared, 3.5 times 10 to the power negative 4 squared, divided by C minus X, which is 3.5 times 10 to the power negative 4. Find C. That's it. Find C. Okay? Remember, when you have an option, look at X. طلعوا على X. Okay? If X is very low, you can actually neglect it. You can neglect it. It's not wrong. When you neglect it, you get C is equal to 6.805 times 10 to the power negative 3 mole per liter. You can neglect it. If you do not neglect it, if X is not neglected, and I do mean only this. ليش بقدر بس أعمل neglect for this x؟ لأنه you are neglecting it with respect to c. Because you are neglecting it with respect to c. Remember the rule that you used to take before, that minus x or plus x, you can neglect it if the error is actually less than 5%. How can you check the error is less than 5%? Neglect x, يعني put this equal to 0. Find c, ورجعوا خدوا x divided by c. Is the error less than 5%, يعني 0.05, then your neglect is validated. If x is not neglected, c will be, I think, around 7 times 10 to the negative 3. Now, if you look, not much difference, okay? But you can always neglect, however, check the error. Check that your error is less than 5%. So 6.8 times 10 to the power negative 3. 31. Potassium hydroxide. We all know what potassium hydroxide is. Ionizes completely in water according to the following equation. Yes, it gives you K plus and HO minus because it's a strong base. The initial concentration is 10 to the negative 7. دغري بنتبه. 10 to the negative 10. This is less than 10 to the negative 8. When it's less than 10 to the negative 8, دغري pH equals 7. The pH of the solution is exactly 4. The pH of the solution is exactly 9. Okay, the pH of the solution is between 7 and 8. The pH of the solution is exactly 10. The pH cannot be determined. هلا, it's exactly 4. This is absolutely not true. 9 كمان not true. 10 also not true. In fact, when it's less than 10 to the negative 8, the pH is 7. Okay, but remember that we said 7 because it's approximated and seen al base itself, and we only took into consideration the autoionization of water. مشان هيك طلعت ال pH equals 7. However, if you do want, وهون دغري خلاص, the answer is this one. pH is between 7 and 8. But if you do want to find the real concentration, like what we did in the course, what do you do? What do you do? أول شيء, this is the concentration of your base, okay? The second, you have to take the autoionization into concentration, which is basically H3O plus with HO minus. When you add an acid to a base, ببطلوا 10 to the negative 7, 10 to the negative 7, it's actually X plus 10 to the negative 10. Now, KW اللي هي 10 to the negative 14, we already did this in the course, is equal to X into X plus 10 to the negative 10. Find X. It will be very close to 10 to the negative 7. Very, very close to 10 to the negative 7. When you do find X, you will get 0.9995, I think either yet 29 or 39s, times 10 to the negative 7 molar. The pH هي minus log X or 14 plus log X plus 10 to the negative 10. And it will be between 7 and 8 لأنه it's slightly basic because you added a small amount of base. أكيد you don't do this بس بتفكروا إنه the base added has a very low concentration. يعني the autoionization of H2O is dominant. However, لما بتكون ال autoionization of H2O dominant يعني ال pH هي 7. نحن هيك اتفقنا بالerrors. What is it that you added? You added a base. هيدا ال base will slightly raise the pH of your solution. بس من دلنا نقول 7. If you calculate it, if you truly calculate it, you will get 7.000, I think, 2 something. So it is 7, but it's slightly greater than 7 because you added that base. So you can calculate it. You don't need to. خلاص pH is approximately 7. It's slightly larger than 7. نفس الشيء if you add an acid like HCl and suppose that the concentration of HCl is 1 times 10 to the power negative 9, this is less than 1 times 10 to the power negative 8. دغري فيكم تقولوا إنه pH هي 7. In reality, when you forget validity and actually calculate it, you will find that the pH is slightly lower than 7, 6.999 something. Because when you only have autoionization of water, you have 7. زيدوا شوية acid أو شوية base تنزلوا شوي تحت 7 أو slightly above 7. You add a considerable amount of an acid or a base, you go way below 7 or way above 7. Good. Number 31, that's a blank page. Number 32, let's start a new recording.